take a human body and strip away the skin, the muscle and the bone, what are you left with? You're left with the nervous system, the electrical grid that tells the hand to move, the heart to beat and the brain to panic. The cloud is no different. We spend so much time obsessing over the organs of AWS, the S3 buckets, where we store our memories, the EC2 instances that do the heavy lifting, but we almost totally ignore the nervous system connecting them all. I'm talking about Amazon SNS, the simple notification service. It sounds harmless, doesn't it? Simple notification, like it's just there to send you a push alert when your Uber Eats arrives. But that is a lie. SNS is the central nervous system of modern distributed applications. It passes the most critical signals, application secrets, personally identifiable information and operational commands. And here's the scary part. Unlike an S3 bucket, which everyone knows how to lock down, this nervous system is often left wide open. Today, we are going deep. We're going to dissect the architecture of SNS. We're going to learn how to exploit it using a vulnerability called the confused deputy. And I'm going to show you exactly how attackers can drain your bank account or steal your API keys without you ever noticing. Buckle up, we're hacking the nervous system. Alright, before we break it, we have to understand how it works. To effectively assess security, you need a nuanced understanding of intended behaviour. In the old days, if Service A wanted to talk to Service B, they just talked, tightly coupled, but that doesn't scale. If Service B crashes, Service A starts screaming into the void. So AWS uses a publish or subscribe model, or pub-sub. In this model, the publisher sends a message to a topic. Think of the topic as a logical access point, a megaphone. The topic then takes that message and fans it out to every valid subscriber. This is great for developers, but it is a nightmare for security. Why? Because of the trust boundary. The publisher doesn't necessarily know who is listening, and the subscriber doesn't necessarily know who is shouting. If I, as an attacker, can subscribe to your topic, I get a copy of every single email, log, or secret you send. Conversely, if I can publish to your topic, I can inject malicious payloads into every single one of your backend systems. Now, when you're doing reconnaissance, whether you're a penetration tester or a blue teamer, you need to look at the type of topic. You've got your standard topics, best effort ordering, unlimited throughput. These usually carry logs, metrics, general noise, valuable but maybe not the crown jewels. But then you see a FIFO topic, first in first out, strict ordering, no duplicates. Why do developers use FIFO? They use it for financial transactions, ledger updates, stock trades. If you are on an engagement and you see a FIFO topic, your ears should perk up. That is a high value target containing business critical logic. You just found the money pipeline. So we know what the pieces are. Now let's talk about how to trick them. One of the most dangerous vulnerability classes in the cloud is the confused deputy. This is a bit complex, so stick with me. Imagine you have a security guard at your office building. That's AWS SNS. And you tell the guard, hey, if a guy named Steve from the cleaning service shows up, let him in. Sounds reasonable, right? Here is the problem. In AWS, services like S3, simple storage service, act like the cleaning service. You might write a policy that says, allow S3 to publish to my SNS topic. You think you are allowing your S3 bucket to publish notifications when a file is uploaded. But if you write the policy like this, you have made a grave mistake. This policy trusts the S3 service globally. It doesn't check which bucket, it doesn't check which account. So here is the attack. I, the attacker, create my own S3 bucket in my own AWS account. I configure it to send notifications to your SNS topic, ARN. Because your policy trusts s3.amazonors.com, the guard lets me in. Now I can upload a file to my bucket and your application reacts to it. I can inject phishing links that get SMS'd to your employees. I can send malformed JSON that crashes your backend Lambda functions. I can trigger millions of events and blow up your AWS bill. This is a classic failure of identity. The fix? You have to use global condition context keys. You need to add a condition that checks aws.sourceAccount or aws.sourceArn. You have to tell the guard, only let in the cleaning service, if they are cleaning my office. If you don't enforce source account, you are effectively letting anyone with an AWS account knock on your door. Okay, enough theory, let's get our hands dirty. You've got a set of compromised AWS credentials, maybe you found them in a GitHub repo, maybe you phishinged a developer. How do you map out this nervous system? We call this living off the land, using the native tools available to us. Step 1, who are we? Always run AWS STS get caller identity. Are you a root user, a constrained role? This sets the stage. Step 2, discovery. We run AWS SNS list topics. This gives us the ARNs, the addresses, look at the names, prod billing alerts, dev test, password reset tokens. The names often tell you exactly where the treasure is buried. But the real gold mine is in the attributes. Command AWS SNS get topic attributes. This returns the policy JSON. This is the crown jewels of Recon. You are passing this text for one specific thing, principal star. If you see an asterisk in the principal field or AWS.star, that topic is public. Anyone can subscribe. Anyone can publish. It is game over. Now, manual CLI is cool, but we are lazy hackers. We want automation. Enter Pacu. It's basically Metasploit for AWS. Pacu has a module called SNS Enum. It iterates through every region, it lists every topic, it grabs every policy, and it automatically flags the vulnerable ones for you. It builds a local database of the target's infrastructure while you sip your coffee. One detail you cannot miss, subscriptions. Run AWS SNS list subscriptions. Look at the endpoints. Are they corporate emails? Or do you see developer.daveigmail.com? Or maybe a webhook pointing to a non-corporate domain. Finding an external email address in a production topic suggests data is already leaking, or someone has already been here before you. We've done our recon. We found a vulnerable topic. Now, let's hurt them. I want to walk you through a real-world scenario from CloudGoat, which is a vulnerable by design training environment. The scenario is called SNS Secrets. Here is the setup. We have a low privilege user. We run our Pacu enum module, and boom, we find a topic, CG public topic. We check the attributes, and sure enough, principal is set to star. This is an open data pipe. Just like an open S3 bucket exposes files, a public SNS topic exposes data in motion. So we subscribe, we tell AWS, hey, send copies of these messages to attackerevil.com. AWS sends us a confirmation email. We click the link. We are in. Now we wait. We are performing a man-in-the-middle attack, passively listening to the nervous system. And there it is. A few minutes later, a system notification fires. Here is the API key for the legacy payment gateway. Developers often treat internal topics as secure channels. They dump secrets, passwords, and PII into them thinking, it's internal, nobody can see this. Wrong. We just saw it. We take that key, we curl the API gateway, and we have full administrative access to the application, from a simple notification to total compromise. But maybe you don't want data, maybe you just want to watch the world burn. Let's talk about SMS pumping. SNS supports sending text messages. If an attacker finds a topic that publishes to SMS, and they have publish rights, they can automate a script to send thousands of texts to premium rate numbers they control. It's called toll fraud or international revenue share fraud. They drain your AWS credits, generating massive bills in hours. You wake up the next morning, your data is fine, but you owe Amazon $50,000 in SMS fees. This is resource exhaustion, and it is financially devastating. Okay, take a breath. That was the scary part. Now, how do we stop it? Defense is not just about blocking access, it's about visibility and scrubbing. First, eliminate public access. Audit your policies. If you see principal, delete it immediately. Use Prowler or Scout Suite to find these automatically. Second, network isolation. If your messages are internal, why are they traversing the public internet? Use VPC endpoints. Private link. You can actually add a condition to your policy. AWS source VPCE. This says, I don't care if you have the password, if you aren't physically inside our virtual private cloud network, you can't touch this topic. It creates a hard network perimeter. Third, data protection policies. This is the cool futuristic stuff. AWS SNS can now act as a data loss prevention DLP engine. You can configure a policy that scans the message payload in transit. It looks for credit card numbers, social security numbers, or specific regex patterns. If it finds them, it can redact or de-identify the data before it hits the subscriber. So even if an attacker hacks the endpoint, they just get a bunch of hashtags. This is defense in depth. And finally, encryption. Server-side encryption, SSE, is great, but don't use the default AWS keys. Use a customer managed key, CMK. Why? Because CMKs have their own policy. So even if I trick the SNS policy, the confused deputy, I might still get blocked because I don't have permission to use the encryption key to decrypt the payload. It's a second lock on the door. Amazon SNS is deceptive. It's called the Simple Notification Service. But there is nothing simple about the security implications. It connects your database to your users, your servers, to your analytics, and your billing account to the world. If you ignore it, it can be a gateway for data exfiltration, a command and control channel for lateral movement, or a mechanism for financial ruin. But if you respect it, if you lock down the policies, encrypt the payloads and monitor the traffic, it becomes the robust, secure nervous system your cloud needs. So here is my challenge to you. Open your AWS CLI right now, run AWS SNS, list topics, pick one at random, look at the policy. Does it rely on s3.amazonors.com without a source account? Is it public? Go check your nervous system before someone else does.